Another good example of a perturbation to our climate and Earth system is, of course, the volcanic eruptions. We have several examples, and the last one that was well observed was the 1991 Pinatubo eruption in the Philippines, and you can see these are satellite measurements of optical depth of aerosols, which is a measure of aerosol loading in the atmosphere, amount of dust in the air column. So it happened on 15th June. So this is looking at data before the eruption, and this is just during and after the eruption. You can clearly see massive increases in the optical depth, so aerosol loading that quickly spread around the world by the trade winds and the upper level circulation. Obviously, volcanoes put stuff in the upper atmosphere, so stratosphere can be critical. Stratospheric circulation can be critical, and things that get thrown into the stratosphere can stay there for a long time. So you have to see where the ash was put in. For example, a high latitude volcano like in Iceland may have an easier time pumping stuff into the stratosphere because the tropopause drops from about 12 kilometers in the tropics or higher to about 8 kilometers at higher latitudes, because the atmosphere is getting colder and denser and shrinking. In the troposphere is, right? So then it is in August and September, so you can see that by September the perturbation is still huge, but these are also seasonal changes included in these, and it is still clear that the optical depths were beginning to drop off again, or aerosol loading was beginning to drop off again. So here is the temperature change from the time of Pinatubo eruption. So it is comparison of predicted and observed. So models took the volcanic eruption forcing aerosol loading. So you take the radiation, you put all these aerosols observed from satellites, let's say, and you tell the model to say what do we expect, and these aerosols, sulfate especially, block sunlight, reflect, scatter sunlight, and cool the global temperatures. In the examples go all the way back to 1815, which I think Krakatoa maybe, you have to look it up, which created the year without summer in 2016. Books like, I think, Frankenstein and which one, the other one, Dracula, anyway, many authors huddled together and wrote horror stories around that time, crop losses over England and so on. And the observed temperature changes match very well. So typically what is done is to look at composites of volcanoes to separate the impact of volcano itself from other things like La Nina or El Nino. What we do is take multiple volcanoes for which you have data, and you compute air temperature anomalies before the eruption and after the eruption, and typically shows that you have some natural variability going on before the eruption, so several years before, and then after the eruption happens, all volcanoes end up cooling the global climate by various amounts, which last for number of years depending on how strong the volcanic eruption was and how much aerosol loading was put into the stratosphere, because stratosphere has no weather, things can stay there for a long time. Okay, and then you recover to the natural variability after some years. In terms of Earth system feedback, there are also estimates of the shortwave and longwave forcing at the surface, which means how much the shortwave was reduced, and in response, longwave was reduced as well. You can see there are a couple of watts per meter squared, which is fairly significant as what accomplishes these global coolings. And this is the upward long wave, and these are the different satellite estimates. Basically, the argument is that there was significant surface flux forcing which impacted soil moisture, crops, carbon cycle, obviously respiration rates, photosynthesis rates, and so on. So that is the Earth system feedback we want to understand. Typically, climate and El Nino people worry about just the temperature perturbations or aerosol and direct and indirect effects on clouds and rainfall rates, rainfall distributions, types of rainfall, and so on. But here we want to worry about Earth system feedbacks, but the data to actually link all the way to the Earth system feedbacks in soil and vegetation and carbon cycle is not that easy. But the way it works is, once 1991 we were still not completely into Earth system models. IPCC simulations were still mostly being done with physical climate models with sea ice and other things. So now as we go forward, we have satellites and other measurements to try to track Earth system feedbacks as well. Okay, so this is showing the warming record again, and with detectable dips in the warming rates because of various volcanic eruptions from Mount Ogung, El Chichon in Mexico, and Mount Pinatubo, Philippines. And interestingly, I think this one was also an El Nino, if I'm not mistaken, but this 82-83 El Nino, which was one of the strongest in the 20th century records. Pinatubo happened around 92-93 El Nino, which was milder. Pinatubo overall was a weaker eruption than El Chichon, but modeling exercise from GFDL, this is from GFDL, show that the impact of Pinatubo was larger on damping the impact of El Nino. So here, this was basically 82-83 was ending, and we were going into a La Nina. So there are several studies now arguing whether volcanic eruptions can induce El Ninos and so on. But this is, I'm using as an example to say that magnitude of the eruption and the amount of aerosol loading and other chemicals, carbon monoxide, methane, carbon dioxide, whatever, depends on how it is distributed and where in the air column. But it definitely modulates natural variabilities like El Nino. We will not debate about whether volcanoes can cause El Ninos, but there is some literature on that you can look up. Okay, considering the perturbation and the patterns of surface fluxes, it is possible, because El Nino can be triggered by, let's say, changing the trade winds and reducing the upwelling, and then kicking off east-west temperature gradient perturbation, pressure gradient perturbation, associated wind perturbation. So anything that perturbs the radiative forcing can presumably set off an El Nino.